All right, you guys, let's match these real-world situations to the graphs at the right. There's 4 situations, 6 graphs, so we won't be using 2 graphs. Situation A, during the first few years, the number of deer on the island increased by a steady percentage. As food became less plentiful, the growth rate started slowing down. Now the number of births and deaths is about the same. So this is going to have the independent variable, the x for this one, is going to be, let's see, the x is going to be years, right? And the y will be the number of deer. The number of deer. So at first, the number of deer on the island is increasing by a steady percentage. So I can rule out graph 4. I can rule out graph 4 because that makes it look like that's the x-axis, and that's not true. I meant just to cross it off. I can rule out graph 4 because that starts out decreasing, right? Looks like that's the, oh, and graph 6 is decreasing also here. So I can rule that out. So it's got to be one of these other graphs. Graph 1, it looks like graph 1 is increasing quickly and then decreasing. And it doesn't say that the deer ever start to decrease. It says that they start to level off. So I'm going to say it's got to be graph 3 or graph 2 or graph 5. So if we look at graph 2, it looks like, you see how the second part of the graph is steeper? The second part of the graph is steeper than the first part. That means that it's getting faster, and that's not what happens, right? And then if you look at graph 5, it looks like it starts out fast, but then it kind of slows down, and then it levels off. This first part right here is kind of exponential, and we know that exponential means it's growing very fast, and then it kind of tapers off. So graph 5 is going to match situation A. Situation B, in the northern hemisphere, the amount of daylight increases slowly from January to February, faster until mid-May, then slowly again until the maximum in June. So maximum, that's a key word I want you to realize. So let's take a look at maximum. Then it decreases slowly through July, faster from August till November, and then slowly until the year's end. So really quickly, let's define our variables. Our x, or our independent, is going to be months, and our dependent, or y, is going to be the amount of daylight. Okay, but let's take a look. That word maximum means that my graph is going to have a maximum. So what does that mean? It means it goes up and then it's going to come back down. So it could be graph 1, and there's the maximum point for graph 1. It could be graph 3, and there's the maximum point for graph 3. It could be graph 6. Graph 6 has a maximum and then it goes down, but it doesn't start going up. So the question is, which one of these two graphs, graph 1 or graph 3, looks like it's starting out a little slower and ending a little slower? And if you said graph 3, you are correct. This part here, starting off slower, then getting faster, faster, maximum, coming down slower, and then getting faster, faster at the bottom. So situation B matches graph 3. So now we have graph 3 matched and graph 5. Situation C, If you have a fixed amount of fencing, the width of your rectangular garden determines its area. If the width is very short, the garden won't have much area. As the width increases, the area also increases. The area increases more slowly until it reaches a maximum. As the width continues to increase, the area becomes smaller more quickly until it is 0. Okay? That one is going to be, so it's going to have a maximum, and it's going to start off small and end at 0. I hope you already know that that's going to be graph 1. But go ahead and let's define our variables for C. I'm going to do it here at the bottom for C. Our X is going to be our length, or width. Okay? And you guys did this last year in 8th grade when you were talking about fence and area. X is going to be our width, and Y, our dependent, will be our area. And last, your cup of tea is very hot. The difference between the tea temperature and the room temperature decreases quickly at first. So it's starting off decreasing, and there's only one that is. That's going to be graph 4. And as you can see, it slows down. It starts off pretty fast, and then it slows down. And let's go ahead and just define the variables. Define it in your head. What is on the denominator? It looks like we have, it says the difference between tea temperature and room temperature. So the question is, what's getting lower? It's going down. Is that going to be tea temperature or room temperature? Well, it's your tea that's going to be getting cooler. So your, for D, your independent is going to be the room temperature. And since it's the Y value that's going down there, that's going to be your T temperature. All right, practice the practice problems that you have, and you should have time in other sections to also be practicing those.